So this is the last problem that we talked about yesterday. So chain rule, we're still looking at this idea of chain rule. Chain rule is two functions inside of one function inside, at least one function inside of another function, okay? So when we look at the chain rule, you look at, well, first thing we look at is the outside and then the inside, or the inside and the outside, whichever one we have to differentiate the differences between the outside and the inside, okay? So, and then once we do that, we take the derivative of the outside, inside stays the same. We take the derivative of the outside, inside stays the same. And then I chain on with multiplication, the derivative of the inside. And then there's still an inside on that, then I keep going until I'm done going inside, 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 okay? That's the chain rule. All righty. So, okay, so deriving and identifying the inside and outside gets tougher when you have functions with multiple inside functions. When this happens, you peel the function like an onion, okay? Taking the derivative of the outside of the remaining function that has not been derived yet and keeping the inside function the same until you work your way to the innermost function, okay? So what we're gonna do right now is we're gonna determine what's the outside function and how far does this guy go inside, okay? So we're gonna do that with the first one, A. So we're not doing derivatives right now. We're just figuring out what's the inside, how far does this guy go outside, how far does it go inside? Well, the first thing is the outside, right? The outside's always the easiest because that's everything. That's the whole thing. Okay, that's the whole thing here. So, but before I write this, before I do any work, right, we should rewrite it. Always want to rewrite it. Couple things that I don't like. First thing I don't like is that the cubed is where trig values put it, right? Trig puts it here. I don't really like it there. Okay. So actually, let me write this down here. So I'm going to rewrite it. I'm not doing anything right now. I'm just rewriting it. So sine of root 4x plus 1 the entire thing is cubed. So it means whatever I get as an answer, sine of that angle, I'm going to cube that. Okay. And then there's one more thing to do. What is that? What am I going to do now? What's left to do before I can start looking at the inside and outside? Yep. Take the square root away. So let's rewrite it one more time. So instead of, all right, 1/2. Okay. Here's a question. Looks like I have an exponent to an exponent power. The rule for exponent to an exponent power is multiply them, right? So can I multiply the 1/2 and 3 together? Can I multiply those to make 3/2? The answer is no, why not? I saw a few of you go like this. You're right. A few of you shake your head no, that's correct. Why not, Diane? Exactly. The 1/2 right here only goes with the angle. It only goes with that angle there. That's it. It doesn't apply to anything else. The third applies to everything. Okay. If they apply to the same thing, go for it. But the 1/2 and the third power, they apply to different things. So if they apply to different things, I got to leave it like that. Okay. But it helps us to see what's inside and what's outside. Okay. So let's rewrite outside. So we're going to go outside first. Obviously, the outside is the whole thing. Okay. So I'm going to rewrite it. That's the entire thing written. Okay, that's the outside. Let's go inside one. Okay. What's going to be the inside? Not looking at the inside yet. I'm just looking at one layer in. One layer in. Well, isn't this part? This part is the outside. That's the outside there, right? So the first thing I would do if I'm doing derivative of this is to take the derivative of that yellow stuff, something to the third power. Okay, so let's go one inside. Inside would be sine of 4x plus 1 to the 1/2 power. So that would be sine. We've done problems like that. We've had problems like that where we had sine of something, tangent of something, cosine of something, right? The outside is the sine part. Okay. So let's go one layer into that. What would a layer in from this one look like? What would a layer inside of that look like? Close. 4x plus 1 to the 1/2 power. To the 1/2 power. Everything I didn't highlight. Everything I didn't highlight, right? And then that would only refer to this stuff right here on the outside. So you're always looking for the stuff I didn't highlight. That's the inside. And there's still an inside, which is what Roman said. Now we're going to finally get to that inside, 4x plus 1. And then we're done. That's the inside. So this guy's going to have 1, 2, 3, 4 rings, 4 chain links, because I have to find derivative 4 times. Okay, that's what I would do for that problem there. Okay, let's look at the next one now. It's another, the ones with sine code, the trig ones are the ones that usually have the most amount of layers, because you got to do the trig and you got to do the angle separately. Because, and then if like this one here, the angle had a root. So that was a further level. This one over here, the angle doesn't have a root, but there is a root on the outside. So the first thing I got to do is rewrite it with powers. Okay, so now here, could I do quotient rule for this problem? Yes, you could. You could absolutely 100% do quotient rule for this problem here. Might be easier to do it that way. But for right now, we're going to do chain rule. I'm going to show you how to do this with chain rule. So chain rule, we don't want numerator, denominator. We don't want this. So what I'm going to do is I'm going to move it to all 1. So how do I move that root with the tangent 4x squared plus 1? How do I move it up so that there is no denominator? What am I going to do? Take it to the -1 power. That's what I'm going to do. So I'm going to write everything in there. to the negative 1 power. Oops. Still have a root though, so I got to take care of that root too. Okay. So before I do a derivative, or before I look on the inside of the inside, the outside, and then the inside, and then go layers in, I have to make sure that it's ready to be ready if I was going to do this one. Okay, so if I was going to find the derivative. So here we go. We got 3. And on the inside here, let me put brackets instead here. I have tangent of 4x squared plus 1, parentheses. That's to the 1/2 power, close brackets, negative 1/2. Can I, this one has the same as last one, right? The last one kind of had a power to a power, right? We had 1/2 right here. We had 1/2 power to the third, but we said we couldn't do that because the 1/2 only applied to the angle and the third applied to the whole thing. How about this guy over here? Can we multiply 1/2 and negative 1? Do they apply to the whole? Do they apply to the same quantity, or just, or is it the same situation as the last one? Well, what does 1/2 apply to? Does 1/2 apply to 4x squared plus 1, or more than that? More than that, right? It applies to this whole thing right here, right? It applies to this whole thing. Okay. What about negative 1? Does that apply to the same thing? It does. It does. So we're able to get rid of one layer just by combining those two. So I can combine 1/2 times negative 1. So 1/2 times negative 1, negative 1/2. So that gets rid of one layer. Oops, don't need brackets. So it got rid of one layer. Okay. Well, this is going to be the outside. Obviously, this is going to be the outside because it's the whole thing. So let's say I was going to find the derivative of this. What would I do? How would I find the derivative of the outside of this guy? What's the only parts I'm looking at when I want to find the derivative of the outside? You Rush? There it is right there, yeah. 3 is the coefficient, right? And something to the power of negative 1/2. That's how I would find the derivative of that. Move the negative to the 1/2 to the front, multiply, take away a power, do that. Good. Okay, let's go inside one. Inside of the yellow. What's going to be inside of the yellow? Everything that's not highlighted, right? The tangent of the angle. Tangent of 4x squared plus 1. Now, if I was going to find derivative of that guy, what would I do? No, so that's going to be the next layer. You're right. That's the next layer. But if I wanted to find derivative of this guy, how would I do that? That's it. Yeah, just find derivative of tangent. Just find derivative of tangent. Leave everything else the way it was. Leave everything else the way it was. The last layer is where we'll get to the 4x squared plus 1. So use power rule, so it'd be 8x. That's it. Okay. So layers upon layers upon layers. Sometimes they are only 2 layers. Sometimes there are more than 2 layers. This one, there were 3 layers. The last one we did, there was an extra layer. I think there were 4 layers. 1, 2, 3, 4. Yeah, 4 layers. So it just depends on the problem. But at every step, all you're doing is finding the derivative of that layer that you're at. So if I'm on the outside, I'm only finding the derivative of the outside. That's power rule, right? Move the 3 to the front, take away a power, done. Then I got to find the derivative of sine, cosine. Everything else stays the same. Next chain, find the derivative of the outside here. That's another power rule. 1/2 in front, take away a power. Last step, find the derivative of this. They all get chained on. So it's really 4 mini problems, okay? That's what the chain rule is, just a bunch of mini problems together that you chain together with multiplication. So like I said, the hardest part of this is figuring out how many layers and what is the outside. Okay. All right, so now let's bring back this guy here. So now we're actually going to go through the steps and actually derive the thing. Well, we know what the layers are, right? So first of all, let's rewrite it how we rewrote it to begin. Okay, so let's rewrite it how we rewrote it at the beginning of the last problem. Okay. Okay. Then we said the outside layer was this part here. Something to the 3rd power, right? We said the outside layer was something to the 3rd power. Something to the 3rd power. I don't care what that something on the inside is. I'll deal with that later. I'm going to deal with that later. But right now, I just got to do something to the 3rd power. Well, if it's something to the 3rd power, that's power rule, right? So I'm going to move the 3 to the front. Everything on the inside stays the same. Take away a power. Done. That's the outside layer. Okay. Now we're going to move inside a layer. We said that the inside of the layer, the inside layer for this guy, the first inside layer was the sine, right? We said we did first one's done. Outside is done. The inside though, we said sine, right? Sine was that layer now. So what's the derivative of sine? Cosine. Everything else stays the same. So 4x plus 1 to the 1/2 power stays the same. Okay. We've got 2 more layers. The next layer was this pink magenta color. 4x plus 1, something to the 1/2 power, right? Something to the 1/2 power. Well, that's just power rule, right? Power rule says move the power to the front, subtract the power from what you already have, what you had before. So I'm going to move the 1/2 to the front. Keep what was already in there. Subtract the power from the end, or from the original power. One more chain. One more chain. Probably the easiest one, right? The very, very inside, 4x plus 1. 4x plus 1. What did I do? That should be negative, yeah. The inside here is just 4x plus 1. The derivative of 4x plus 1, plain old 4. Tack on a 4 at the end. We're done. The calculus part is done. Now I got to kind of combine these things. They're all multiplication, so I can multiply a lot of the coefficients. Coefficients I can multiply. So let's see. I have a coefficient of 3 out here. This one has a coefficient of 1. This one has a coefficient of 1/2, and then this one has a coefficient of 4. So I can multiply all of those guys together since they're just coefficients being multiplied. Okay, so when I multiply all of those guys together, I get positive 6. 3 times 4 is 12. 1/2 of 12 is 6. Okay. Anywhere there was a 1/2, I'm going to put the root back. Okay, anywhere there was a 1/2, I'm going to put the root back because that's how it started. So I see I have a 1/2 in here. And put the root back there. Same thing here. Okay. So sine, and then instead of 1/2 power, I'm just going to put the root back there. Squared. 4x plus 1. This guy, the last guy right here, 4x plus 1 at the end, that has a power, right? That has a power negative of 1/2. So it's going to have a root, but it also has a negative 1/2. So when I put that root back, I'm going to put it on the bottom because it has a negative power. Done. Here. Or you can put the squared here. You can, it's just preference really, but you can move the squared here if you want. So you get rid of, that would get rid of these parentheses or these brackets here. You can do that if you want. It's not, like I said, it's just preference at that point, but that's the only other thing you could do besides that. It's done. So that one had 4 layers. So the first thing when you're looking at these types of problems, the first thing to do is to try to figure out what the outside is, what the inner part is, what the inner part is. Once you lay those out, then you're just finding derivatives of each, which you guys have done before. Okay, especially with these ones that have 3, 4 layers in. Okay, so let's look at the one we just did. This one's not that bad, actually. Remember, this one only has 3 layers. It looks worse than it actually is. Actually, the last one was harder than this one because this one only had 3 layers. So the first thing I'm going to do is I'm going to rewrite it. So rewrite it like how we rewrote it on earlier. Okay, so I rewrote it as, how did I rewrite it? 3 Oh, here we go. 3 tangent 4x squared plus 1. And then I had -1/2. -1/2. That's what I wrote it earlier as. Okay. Start with the outside. We said the outside was this part here. 3 coefficient something, 3 times something to a -1/2 power. That's what we said 2 problems ago. That was the outside. That's a power rule. Move the 1/2 to the front, multiply it times +3. So if I multiply -1/2 times 3, I get -3/2. Everything else stays the same. Subtract 1 from the power. Now it's -3/2. If I subtract 1 from the power negative that was already there, -1/2, I get -3/2. Okay, that's the outside layer. Then we said the inside layer, or one layer inside of that, was just the tangent part, right? Just the tangent part. So what is derivative of tangent? Secant squared. So what I'm going to do here is I'm going to put secant squared. Everything else stays the same. Everything else stays the same. One more layer. The layer on the inside. 4x squared plus 1. The derivative of 4x squared plus 1 is just 8x. Okay. Calculus is done. We're done with the derivatives. But like I said, the vast majority of the time, almost every time you see these types of chain rule problems, it's going to be a multiple choice question. So the key with multiple choice is matching it up to one of the ones that they give you, A, B, C, D. That's not going to match because it's not simplified. Okay, you have some coefficients. We have some coefficients here that we can combine. I have -3/2. This one doesn't have a coefficient here, just a 1. And then an 8x at the end. So I can multiply those two guys together. So what do I get if I multiply -3/2 with +8? -12? -12x, yep. -12x, good. Those are taken care of. And then I see I still have a negative exponent, right? I'm done with the problem. So I'm going to take care of the negative exponents. It's okay to have negative exponents until you're done with the problem. I'm done with the problem. So now I got to clean it up by looking at presentation, okay? So this guy here says I need to move to the bottom. Okay, so I'm going to have a denominator. So I'm going to have tangent of 4x squared plus 1. That's going to be to the 3/2 power. 3/2 power. Now, they might have, instead of 3/2 power, they might have the square root of this to the 3rd power. Okay, they might have, instead of the 2 down here, they might just say 3 and then have the square root of this. That's the same thing. It's just preference. Like I said, it's just preference at that point. Okay, got that. And then the last part is this secant squared. Well, this secant squared doesn't have, it has a power of 2, but that's positive 2. So I can put it right here. Okay. The key to these is going step by step, not going too fast, not worrying about the step after the next step. Just worry about the step that's in front of you. You know what you have to do. Find the layers, find the derivatives, chain them together, simplify. That's all you have to do, okay? But the problem is, when you look at a problem like this, I know this is what happens. I've been teaching this class long enough. What happens is, you look at that problem, you're just like, oh my gosh. You think of step 5. Don't think of step 5, right? How do you eat an elephant? Does anyone know how you eat an elephant? Little bits at a time, one bite at a time, right? That's what you do, okay? This is an elephant, I know it is, but think of little bits at a time. Think of the step in front of you, think of the step in front of you, think of the step in front of you. Don't think of, how am I gonna solve this problem? Well, you're gonna do the first step. You're gonna take the first step, which is set it up like, find out where's the outside, where's the inside, where's the inside, where's the inside, okay? Okay, let's see. I think we got time for one more. Let's see. I don't want to do those right now. Okay, let's try this one. This is the last one we'll do today. Last one we'll do today. Okay, so again, this is an elephant. Could be an elephant. We don't know how big it is. I'm not worried about the end product. What am I going to do? What's the first thing I got to do? What is the first thing that you're seeing right now that I have to do? That's the first step. Yep. Make the root an exponent. Make it presentable so I can start using some of my rules. Okay, so I have to find the derivative. Remember, the question is asking me to find the derivative. First step, I like that. Okay, so now we're ready to find the derivative. What am I going to do next? Okay, so there is an outside, there is an outside, and there is an inside for this guy here. There is an outside, there is an inside, right? The outside is something to the 1/2 power, and then the inside is there, right? So that definitely we're gonna have to use the chain rule. But this guy over here is not inside that function. What is it doing with the other function? Multiplying. And when we have two functions being multiplied together, what do? Product rule. So we're going to use product rule. Now inside the product rule, we're going to have to do the chain rule. But first step is the product rule. Okay, so let's set up product rule. Product rule says first one, x squared plus 1 times the derivative of the second. So the second one is 2x squared or 2x minus 3 to the 1/2 power. Now that one, to find derivative of that guy here, we're going to have to use the chain rule for that guy. because that guy has an outside and it has an inside, right? It's got 2 layers to it. Okay, so the first thing we're going to do is find the outside. Derivative of the outside. So how do I find the derivative of the yellow? There you go. Move 1/2 to the front. Leave the inside the way it was or is. Subtract 1 power, so it's negative 1/2. Got a chain. What do I do now? Now I got to find the derivative of the green. What's the derivative of the green? 2. Done. Done with that part. Now they have to do the opposite. The opposite said the derivative of the first. Well, what's the derivative of the first? Do I have to use chain rule to find derivative of this guy? No, doesn't have a power. If it had a power, yes, I would, but it doesn't have a power. It's just x squared plus 1. So what's the derivative of this guy here? 2x times this guy over here. Calculus is done. But again, I guarantee you this won't be one of the A, B, C, D answers because we have some negative exponents. I have some guys over here I can multiply, right? So be careful when you're combining like terms with this. Or I have 2 terms. I got that guy and I got this guy. So I can multiply within those terms. I just can't multiply outside of those 2 terms. So if I'm looking over here, I see I have a 2 over here and a 1/2 over here. So I'm going to multiply. What's 1/2 times 2? 1, right? 1. Okay. So I got 1. So these guys simplify to be 1. And then I have x squared plus 1. So I'm going to write x squared plus 1. Okay, got that taken care of. This guy is left here. That guy's got a negative 1/2. So that's going to move to the bottom. Okay, done with that. Well, this guy over here, the only coefficient is 2x. That's the only coefficient. So 2x is going to go over here. And then this power up here is just 1/2. So the 1/2 just means square root of 2x minus 3. Done. Okay. Actually, there's a way to simplify it. I'm okay with that answer. But like I said, it's all about matching what they have A, B, C, D. Okay, so there is a way to simplify it. I'll show you guys tomorrow how to simplify this. But that's the thing. How far do you need to go? As far as until you get an answer. Until I get an answer that matches A, B, C, D, then I'm good. Free response, I'm okay with that. That's okay with me. But again, I don't control multiple choice. Multiple choice is already preset. Okay, so tomorrow we'll go over, I'll show you on, has nothing to do with calculus. How to simplify this has nothing to do with calculus. Okay. Yep, so we'll finish the notes tomorrow. Okay, no assignment. Like I said, I'm not assigning you guys anything yet because we're not done yet. Like I said, chain rule is going to take a couple days, several days, because there's so much that's involved in it. Okay.